Now, if you remember from the one-dimensional case, um, you can determine if your critical point is a minimum or maximum by looking at the second derivative. It's a little more complicated in this case. Um, so this only works when your critical point comes from your two partial derivatives equaling zero. So first you have to have that. So then you compute um, d, which is this. So a simpler, shorter way to write that is d equals fxx fyy minus fxy squared. So this is going to determine, d helps us determine if there's a saddle or not. So I'll skip to step 3. If d is less than 0, then a saddle. If d is greater than 0, then you got two options. It just means if d is greater than 0, then it's not a saddle. So you can kind of do the normal one-dimensional thing, where if your second derivative is greater than 0, then you're curving up in both directions. And if you have the second derivative is less than 0, and you could do xx or yy. They'll give you the same answer then in this case. So then you've got a relative, got that backwards. All right. Relative is it's greater than 0. So then you've got a relative minimum. And then here you've got like a relative maximum because it's curving down. All right. So d less than 0 means you have a saddle situation going on, where in the x direction it might be going down, when the y direction is going up. And then if d equals 0, then the test fails and it doesn't tell you anything. Okay, so now let's do an example.